Hello, I am Levent Batın Öndeş. Today I'll talk about nanotechnology and carbon for Introduction to Nanoscience and Nanotechnology course. First title, what's a carbon? Carbon in Latin, is a chemical element with the symbol C and atomic number 6. It's one of the most important elements of the Earth, constitutes approximately 0.2% of the Earth's crust. You can see carbon in this picture. The next topic is allotropes of carbon. Atomic carbon is a very short-lived species and, therefore, carbon is stabilized in various multiatomic structures with diverse molecular configurations called allotropes. The three relatively well-known allotropes of carbon are amorphous carbon, graphite, and diamond. Once considered exotic, fluorines are nowadays commonly synthesized and used in research. They include buckyball, carbon nanotypes, carbon nanobots, and nanofibers. You can see some allotropes of carbon in right side picture: A diamond, B graphite, C lonsdaleite, D and F fluorines, G amorphous carbon, H carbon nanotube. These different types of allotropes of carbon. The first allotrope is diamond. At very high pressure, carbon forms the more compact allotrope, having nearly twice the density of graphite. Here each atom is bonded tetrahedrally to four others, forming a three-dimensional network of puckered six-membered rings of atoms. Diamond has the same cubic structure as silicon and germanium, and because of the strength of the carbon-carbon bonds, it is hardest naturally occurring substance measured by resistance to scratching. You can see evolution of diamonds in this picture. The second allotrope is graphite. Graphite is a common allotrope of carbon. Each carbon atom is connected to three other atoms in the same plane to form hexagonal rings. The resulting network is two-dimensional and the layers formed in this way are connected to each other by a weak van der Waals force. You can see diamond and graphite in bottom side photo. The last allotrope is fluorines. Fluorines are synthetic crystalline formation with a graphite-like structure, but in place of flat hexagonal cells only. Some of the cells of which fluorines are formed may be pentagons, non-planar hexagons, or even heptagons of carbon atoms. The sheets are thus warped into spheres, ellipses, or cylinders. You can see diamond, graphite, fluorescence, and graphene bonds in this photo. The properties of fluorescence split into buckyballs, buckytubes, and nanobots have not yet been fully analyzed and represent an intense area of research in nanomaterials. The names fluorine and buckyball are given after Richard Buckminster Fuller, popularizer of geodesic domes, which resemble the structure of fluorescences. Buckyballs, buckytubes, and nanobots. The buckyballs are fairly large molecules formed completely of carbon bonded trigonally, forming spheroids. The best known and simplest is the soccer ball shaped C60 Buckminster fluorine. Carbon nanotubes, buckytubes, are structurally similar to buckyballs, except that each atom is bonded trigonally in a curved sheet that forms a hollow cylinder. Nanobots were first reported 2017 and are hybrid bucketip buckyball materials. Buckyballs are covalently bonded to the outer wall of a nanotube that combine the properties of both a single structure. You can see buckyballs, buckytubes, and nanobots. First picture is buckyballs, second picture is buckytubes, and last picture is nanobots. What is nano? Its meaning is about scale. It is so small thing. 1 nanometer is equivalent to a billionth of a meter. This photo is about nanoscience. What is a nanotechnology? Nanotechnology or nanotech is manipulation of matter on atomic, molecular, and supramolecular scale. Nanoscience and nanotechnology are the study and application of extremely small things and can be used across all the other science fields, such as chemistry, biology, physics, material science, and engineering. Advantages of nanotechnology: tight continuous and more effective long protection time, easy maintenance and cleaning for all types of textile products and surfaces, easy and simple applicability to all types of surfaces, high product quality, energy resources, and cost savings. Evolution of nanotechnology and carbon. 1959. Richard Feynman and his speech. He started the nanotechnology in this speech. Its name was Trees Plenty of Room at the Bottom. 1974. Avram and Seiden received the patent for the first molecular electronic device. 1985. Kerr, Kroto, Smale discovered carbon-60. Evolution of nanotechnology and carbon. 1991. Lima discovered multi-volt carbon nanotubes. 1993. Lima and Batın discovered single-volt carbon nanotubes. 1993. After these things, United States of Rice University set up first nanotechnology laboratory. Nanotechnology and carbon. Carbon is a common element. A fluorine is a highly unique form of a carbon, a molecule at the nanometer scale. Fluorines were first discovered in 1985 by Richard Smalley and colleagues at Rice University. Given its resemblance to the geodesic dome created by Buckminster Fuller, it became known as the Buckminster fluorine or fluorine. Nanotechnology and carbon. This commonly known fluorine has 60 carbon atoms, carbon-60. Later discoveries led to fluorine structures with 70 carbon atoms and others. The diameter of carbon-60 fluorine is 0.7 nanometers. You can see in this picture carbon atoms. Its properties of carbon-60 atoms: 1. Superconductor to semiconductor. 2. Radical scavenger. 3. Extreme durability. 4. Easily modified to tailor its properties. Single-volt carbon nanotubes. Single-volt carbon nanotubes, another new form of carbon, were discovered in 1993. The discovery was published in the journal Nature by two groups working independently, by Ijima and Batın. You can see in this picture, left side single-volt carbon nanotubes and right side multi-volt carbon nanotubes. Single-volt carbon nanotubes. A single-volt carbon nanotube ranges in diameter from 0.9 nanometers to 1.5 nanometers, with typical lengths ranging from 500 to over 2000 nanometers, and it can be First, a semiconductor or metal. Second, stronger than steel, yet lighter than aluminum. Third, most efficient conductor of heat. Fourth, easily modified to tailor properties as an ink. You can see in a photo colorful single-walled carbon nanotubes. Why carbon doesn't matter? It is perhaps surprising to recognize that carbon provides a foundation for addressing some of the most serious challenges facing our world. First, demands for alternatives to fossil fuels, energy security, global warming. 2. Drive for efficiency, extend end of life, limit use of exotic materials, energy efficiency. 3. Access to clean water and air, groundwater, desalination. 4. Needs of an aging population, healthcare and advanced therapeutics. Why carbon doesn't matter? For example, lithium-ion batteries used in electric vehicles won't work without carbon. Modern-day water filtration systems need the carbon to capture impurities. Materials processing depends on carbon for lubrication, and synthetic diamonds used to protect materials in UVs industrial environments are made from carbon. You can see lithium-ion batteries and diamond from the carbon. Nanosci. The new class of carbon materials and chemicals that Nanosci manufactures will have a greater and more profound effect than existing forms of carbon in shaping solutions to the four challenges listed above. Nanosci's innovations are derived from its competency in the chemistry of these new forms of carbon, enabling its customers to nanocarbon, enabling its customers to shrink the size of next-generation semiconductors, make flash memory more energy efficient, provide heavy metal-free electrodes for displays, create low-cost organic electronic and medical devices, develop low-cost solar cells. In first photo you can see organic electronic devices and second photo solar cells. Nanocarbon. Develop lighter, weight lower, cost fuel cells for transportation. Make batteries that can be printed. Create water filters that won't fall. Capture free radicals before they can damage cells. Create X-ray sensors that limit radiation exposure. First picture is about water filters and second one is about X-ray sensors. Nanocarbon summary. These highly advanced materials are at the foundation of many more game-changing applications. Indeed, the opportunity in nanostructured carbon is anything but nano. Carbon and nanotechnology are two complementary parts and both of are important to each other. My references is in here. Thanks for listening my presentation.